Not record. Oh no. Okay, so I have a virtual lab also in Recoleta. To compute the gravity model. Okay, can you see? So these are the explanation. Okay, these are the values. Okay, I'm using I think power exponential. Oh yeah. Okay, power and exponential model. Okay, and all you need to do is just put the trip cost matrix, or this is example trip cost matrix. Of course, the number of trip production. Okay, this is 2 rows, so you need to put 2 rows, two separate, and then this one have 3 columns, so then the trip attraction you put 3 columns, and then this parameter you can set any values. Okay, we don't have the TLD, so you can just put any. Okay, and then you calculate there, so you can get the TIC. Yeah, this one is not, we don't have the TLD, so just the basic gravity model. Okay. The one in Excel is much more advanced than this one. So, any question? Trying to understand which part you don't understand, you ask. So you can also use linear programming. Okay. The good things about linear programming model is you don't need to use the full OT matrix like TLT a while ago. Okay. But at the same time, okay, the result of linear programming sometimes get a lot of zeros. That's the problem there. So because it's highly optimized. So, okay. So what is the problem with gravity model? Okay. You assume that TLT is constant, yeah, over many years. So sometimes this is not correct. So, and you also assume that certain criteria, okay, to minimize the difference between model and observe, right? So in that case, you assume certain equilibrium already. Okay. So when you want to use linear programming, screen. Okay, so if you want to use the linear programming, okay, one approach is you want to get, so you want to minimize certain z value, which is the sum of cost and the trip, subject to constraint that the sum of the trips in the row and in the columns, yeah, must be the same as OI and DJ, and then the DIJ must be 0 or positive. Yeah? And then, of course, this cost is actually cost function. Yeah. So for n square matrix, okay, yeah, only n minus 1 cell are positive, the others are 0. So this is the problem with this technique, yeah, because you will get a lot of zeros using this technique. But nevertheless, let's try that. Okay? I will try that. You can go to the next slide. Okay. The next slide in Moodle. Oh, yeah, there. Transportation problems. Okay, can you go to the transportation problem? Okay, so we will use Excel solver, okay, to solve this. Let me show you. Transportation distribution using Excel. Can you see my slide? Okay. So in this case, yeah, you have nodes and links, but this is a simplified version of the whole network. Okay. You only have demand and supply, which is basically the source node and the sink node. Okay, so remember, yeah, each node is either sending node or receiving node. Okay, there is no transshipment node. There is no something in between. So only from source, okay, that represent the supply, and then there is also sink that represent the demand. Okay, so and then you have a link, okay, between the nodes that represent the generalized cost, okay, the distance, time, or cost. So then the question is determine this link flow, okay, at which node should produce item, and then from which location should ship the items to minimize the total cost of the shipment. Okay, so the techniques is let's first give notation. Okay, let's first give notation. So let's give the notation as xij, or in the other slide is dij. Okay, it's the link flow between node I to node j, and then this is the cost function. This is already function of generalized cost. Yeah? And then we use linear programming, yeah, using solver to minimize the sum of link flow multiplied by the link cost. Okay, subject to constraint of the flow. Okay, that receive at node J must be larger than the demand, and the send at node I must be less than the supply. Okay, and then all the flow must be non-negative. Yeah? Mathematically, this is clearer. Okay. Okay, so you want to find xij, okay, by solving this optimization problems, yeah, which is the flow multiplied by the cost, yeah, subject to these three constraints. Yeah. The first constraint is if the node J is a demand node, okay, then the flow in the demand node must be larger than the demand itself. Okay, if the node I is actually a supply node, then the flow in that supply node must be less than the supply. Okay. So then this is our practice. Okay. So I have basically the trip production and trip attraction, which represent the supply, capacity, and the demand here. Okay. And I also have the cost. And this is already generalized cost. Okay. So this is your problem that you need to practice. Okay. And then question is find the cheapest way to distribute this item from A to D, from A to E, A to F, and G, and so on. Okay. So this is what you need to do. You type these values, the one in color. Okay. And then this flow, initially you put 0. Okay. This is the one that we want. And then this one is copy. The demand here is just copy from there. Okay. And then the supply capacities, you just copy from there. Okay. And then this is the sum. The sum is the sum of this row to the each row. The receive here is the sum of each column. Okay. Remember the equation. Okay. The sum in the I must be larger than Dj, and then the sum of the J must be less than the S, the supply. Okay. So that. Okay. So this one is the less than, this one must be larger than. Okay. After that, you multiply. Okay. You multiply the cost with the flow. Okay. Initially, you can put any value, 0, 0, or 1, 1, 1. Then the sum products of these two, you get into objective value, which is Z. Okay. And then you use solver. Yeah. Okay, in Excel, the solver. So you set the objective value is that Z, the sum product, by changing this flow matrix. Yeah, this is the yellow part. And then subject to constraint, the receive must be larger than the demand, and the send must be less than the capacity. Yeah. This one, yeah. The receive must be larger than this demand. Okay. What is the send here must be less than capacity. Okay. That's it. So once you get, you will have this result. Yeah. This is the result. So okay, every one of you, I hope you can practice this and then show that you get this result. Yeah. If you put exactly the same value, you will get exactly the same result in the same objective value also. Okay. Okay. Try that. So once you finish, you show to me. Yeah, you share your screen.
Sir,
Yes.
yeah, just sharing my screen.
Cool. Go ahead.
Okay. In setting up the solver, sir,
Uh-oh.
I use the objective, this one.
Okay.
Then you change the variables on this for the flow matrix
Okay.
using the constraint receive is greater than or equal to demand, or sent is less than or equal to capacity.
Okay.
But this has to be set up as a formula, the
Yeah.
objective,
So you
which is
can just use some product.
yeah, okay.
Okay. That one is the same as some product of dot matrix in the cost. Yeah. This is one by one. Very, very long. Okay.
Okay.
So you just put as some product of the highlighted.
product of these two matrices.
Yes. Comma and then count.
Okay, some product is the Hardamart product.
Yes.
Okay. And then you do again the solver.
Yes. Initially, you can put 11111 or 000.
By changing this. So,
Yes. Good. Oh,
okay.
minimize this one.
Yeah. That's wrong.
Oh,
Range is wrong.
why is it wrong? Oh, your receive and sum is incorrect. That one must be sum.
Yes, correct, sir.
You did not put sum.
Yeah,
Right.
I included the row number 70 on the formula,
Yeah.
on the target.
And then the send also you need to put some of the rows.
Yeah.
That one is a sum. Okay, that one is correct.
Now, yeah. It's
Oh,
the same as
now,
the
yeah,
previous one.
now it's correct. Okay, you got it. Very good. Okay, so how about the others? Come on. If you want, you keep the uh, variable name so that faster and clearer also. Right. So in this example, oh, go. Sorry. So then you want to show. Yeah, on the internet there is a little bit slow. I cannot see your sharing yet. It's okay. Yeah. Try to describe it. Just describe it. Oh, there. Okay.
Hello, sir.
Yes.
I think I'm disconnecting, sir.
Yeah,
Can you see my screen now,
I
sir?
can see your screen.
So, sir, here's the given, sir.
Okay.
The cost per item and the demand and supply.
Okay.
And here's at first, sir, this was started at just like what you said, sir. Just put
Hmm.
00
Okay.
in here, sir. So after that, sir, we put the constraints here, sir. The receive should be greater than or equal to the demand.
Mhm.
Then the sent should be less than or equal to the supply.
Okay.
Then I use the solver, sir. So the objective, the Z,
Mhm.
highlight that cell, sir.
Yep.
Minimum, then changing the values of the flow matrix. Highlight all this, sir. Then I will add the constraints already here, sir, that
Okay.
the receive, the first line says the receive part, then the second line is the supply. Then you will just click solve,
Right.
and it will give the 86,800 and
Right.
here's, sir.
Okay. Very good. Excellent. Okay. Super.
Sir.
Okay. So how about the others? Come on. One more. So while waiting for you, so I downloaded my previous paper. Okay, so this is the paper in 99 a while ago that I mentioned in East Journal. Okay. At the time I was still students. So yeah, the figure is copy paste using paper and real paper. So that's why I cannot put it here. But the technique is simple. Okay? So I have a scenario and I collected the toll price currently, and then we change it in the traffic volume and calculate the distance and revenue and do some optimization, yeah, based on, again, gravity model and elasticity, and then compute the cost also. Yeah. So there are some distance matrix that they provide, yeah, from the tollway authority. So here is the formula you are familiar with, okay? Exactly the same. Okay? So the difference is the meaning. Okay? The meaning now is this is the traffic volume from one gate to another gate. Okay? The OI is actually the entry, the volume in the entry gate. DJ is the volume in the exit gate. Okay? So these are the one that we computed as constant. So at the time we have only 9 gates. Okay. This is and this is the real distance metric in kilometer. Okay. And these are the name of the gates. And we use this one, root mean square error to get the error. Okay. So basically like the SSE. So, and then I tried many different function, generalized cost. Okay. And we run because we know that the LT and so on, we can get the cost function, the A and B, yeah, get the minimize R and SE, okay, and then okay, these are the result of the AI and BJ a while ago, and separate for each vehicles because there are 3 types of vehicles there, so and then we can calculate the distance matrix. Okay, and then from there we can also calculate the actual cost. Yeah, this is the cost. Okay, and then we simulate based on elasticity price. Okay? How much is the actual change in the demand? Okay, so based on that we can compute, okay, the volume elasticity toward the toll price, yeah, for each vehicle type. Okay. After that, of course, we develop many scenarios. Okay. So we can put it as open or closed system. So in that case, binary. So because there are 8 kids, okay, so in this case we have 2 exponent to the 8, which is 256 possibilities. Yeah? But not all of these are actually being used. So in that case, we reduce the number of scenarios, okay, and based on these assumptions. And finally, we were able to generate 6 scenarios. Yeah? So these are the scenarios that agreed by all the authorities. Okay? And then we run again. Yeah. For each scenario, how much is the actual revenue? Okay? And until now, still being used. Yeah, it's already 25 years. They did not change the value. When you come here, you will see the price is exactly the same. Yeah. So, and these are the toll price at the time, okay, that we propose. Yeah. And based on that, we can calculate the cost and benefit. Yeah. Also. Yeah. And these are the PCR and NPV, that rupiah at the time. Okay. And that's it. Okay. So we can, this is one example of using gravity model. Yeah. You can also use for your group project or for your other project. Okay, so one more person, at least, you can share your screen.
Sir, I have a question.
Oh, cool.
I followed exactly what Joben and Vin did, but unfortunately, I can't make the solver function work.
No problem.
So,
You
is it
share, I
okay
will
if I
help.
share my
Yes,
screen
I will
still?
help you. Yes.
Okay.
Okay.
Sorry, can you see my screen po?
Okay, so let's see first. Okay, let's do it so that others can also learn. Okay, so can we close this solver first? Can we give names so that you can say, so the cost, can you highlight this, let's put it there. Can you highlight this part and name it here? Okay, cost. Okay. Okay. And then put this one, okay, name it flow. Okay. And then can I see this part? Can you go here in a sense? Oh, this one must be sum. This is the mistake there. This one must be sum,
Oh,
this row. Okay. The same, the copy. Okay, that's one. Now you go here. Okay, again, you need to put sum of that above. Okay, good. Now copy, okay, and now this array. Wait. Can you put name, receive, and then this array, you put name, send, and then this array, you put name, supply, and then this array, you put name, demand. And then now you fill up this one, sum product of the cost, yeah, just equal sum product, no, sum product, not sum product. Yeah. Okay, sum product of the cost,
sorry.
sum product, okay, open that cost. Okay, you can highlight, you can also type now there, comma, and then the flow. Okay, very good. So you close it. Okay, good. Now you go to a solver. Okay, now set objective is, okay, you can keep name or you can, or this one, M, okay. And then the flow for, oh, okay, good. Solve.
Okay.
Okay, good.
Okay. I missed the
Down,
sum part in the sentence I received.
right.
Sorry. Thank you, sir.
Thank you, thank you. Yeah, so I hope the others can also do the same. You want to, anyone want to share? I give you chance to claim your citation. No problem. If you have problems, so we can do it together. Don't hesitate. And this technique is useful, right? So with this alone, you can become a logistic manager already in any logistic company, isn't it? Right. This is what you are doing, maybe on daily basis, no? In logistic company. Yeah, consultation problem is very useful. Yeah. So yes. Okay. Oh, you don't have solver. Okay, open it. You have solver. If you go to file, you want to share your screen so that I can help you. Okay, you don't have solver. Or you go to, or do you have maybe formulas in your case? No. Home. How about in home?
I think I have an obsolete
Uh,
version of Excel. So
maybe here,
this
home,
one.
and what is the menu? There is no file. How about this home here? I don't know how to get the solver from Mac. There must be a way to get.
Yeah, I will research sir.
Okay, you search first in Google because I'm not using Mac, so I don't know. Okay, there must be a way. Maybe here. I don't know.
Yes, sir. Okay.
Okay. Anyway, even if you use Google Spreadsheet, okay, you can download the extension for solver. So you don't need really to use Excel. Solver in Excel can only handle up to 256. Okay, nodes. Constraint, 256 constraints. Right. You, in this case, you have only 2 constraints only. Not so big problem. Okay. Okay. Anyone else? Anyone else want to share screen? Point 1, point 2. Okay. Okay, Mark Anthony. Okay. Share your screen. Can you? Okay.
Hey, sir. Can you check can you see my screen?
Yeah. I think
Yeah.
seems the same, right?
Yeah, I think, yeah.
Can I see your receive
Receive. This one?
above? Okay, so correct. Okay. And objective, can you go to the objective? Okay, good. Super.
Okay.
Yeah, thank you, Matt.
Thank you, sir.
Yes. So with that, you are okay Cool. Anyone else want to share? Point one, point two, point three. Okay, so in that case, let me come back to the slide of trip distribution. Okay, can you see my slide? Okay, so this is a while ago, right? So now here are the ideas, okay, how you can use the application or simulation of graffiti model, okay, for different ideas. Yeah. Number one, okay, for example, if you want to do some policy alternative regarding the size and the location of new and expanded shopping center, for example, okay, in this case, you alter the attraction. Okay. Or say you want to simulate the increase of residential growth, okay? So you have certain new development or change in the population, okay? So in that case, you change the OI, yeah, the reproduction, okay? So you want to simulate certain economic growth, okay? Again, you can alter the employment. Remember, employment represent trip attraction, so you change the teaching. Okay? Now, if you have a certain new road, then the cost change, isn't it? So in that case, you change the travel time, okay, and then you compute it again. Okay, the same thing. You want to alter, for example, what is the effect of increase on petrol price or bus fare? Okay, so in that case, you can alter the cost function. Okay, and then you can also change this value of the parameter. Okay, because accessibility increase as this parameter decrease. Yeah. So as an example, okay, of all of this, okay, I will just talking about the first one, yeah, so that you can get the idea, okay, that we can actually use graffiti model to do some analysis on shopping mall or shopping center. Okay, so this has been proposed long time ago by a guy named Rayleigh. Yeah? So that's why the name is Rayleigh model. So say, imagine you live in a town. Okay, so this is you. Okay, and there are only two shopping center. Yeah, shopping center A and shopping center B. Okay, imagine like that. Okay, one is larger than the other one is small. So the question is, which one you will go, to A or to B? Yeah? So that is the idea of Rayleigh. Okay, we assume, okay, where people is willing to travel longer distance to reach larger or more attractive shopping center. All right, and then so the likelihood, yeah, so like the probability that the person will shop at particular center will decrease by the distance, okay, as the distance increase, but when the size of the attractiveness of the center increase, okay, for example, larger mall, okay, then you will go there also. And so it will increase the attractiveness and then decrease by the distance. So there are only two factors, isn't it? One is attractiveness of that shopping center or the mall, and second is just distance or the cost. Okay? So here we are talking about generalized cost function. Okay? So you can go to Google and Google this term. Yeah? You will see the Wikipedia. Rayleigh law of retail gravitation. So this will tell okay, that people like to choose to shop certain place based on these two factors, yeah, attractiveness of the shopping center and then the distance. Okay, so how do you measure the attractiveness? Yeah, so one way is to measure the land area, of course. Okay, another way probably the number of shop parking. Okay, another way probably certain shops. Okay, or the number of shops. Okay, or the number of people there. So, okay, and distance, again, distance represents general cost. So not necessarily just distance, but it represents the cost or accessibility, yeah, to go to that shopping center. Okay, so let's put it into formula. Yeah, all these assumptions, let's put it into formula. So let's say you have A, J, attractiveness of the shopping center J, okay, and then you have DJ is the distance from the you as a customer, okay, to the shopping center J. Okay, really it's just based on two shopping center, yeah, I and J. Okay, and his formula is something like this. Okay, so the distance ratio square is the same as attractiveness ratio. Okay, so because of this, so you can put it this way, nah? So di per dj, which is this one, is equal to the square root, yeah, of ai of dj. So if you know the di and dj, and you know the attractiveness, okay, of these two, then you can measure where is the boundary. Okay. So really discuss the boundary. Because of this, we can set up. So let's assume D, okay. Capital D here is DI plus DJ, distance between the two shopping center, and you are in the middle. Okay. So remember that the model is very simple. This is U. Okay. Okay. U. And then this is I. This is J. Okay, so you are in the middle. Okay. Well, middle means not necessarily exactly middle. Can be to the right a little bit, to the left a little bit. Okay. So the total between I and J is capital T. Now, I want to get what is called the point of indifference or the breaking point. Okay, this small d here represent distance from I. Okay, so small d here represent the distance from I. Okay, what is the point of indifference? So of course, this is the formula. Based on this formula, you can calculate t, so that you can get this formula. Let's use this for shopping center. Oh, suppose, okay, you have two shopping center. One is 100 square meter, okay, 100,000. The other one is only 1,000. Okay. So this is small center, and the other one is big. And then the distance is 5 kilometers. So what is the breaking points? You just plug into formula, okay? So you plug into formula. T is 5, right? The distance between two shopping center. And be careful here. Okay. So this one is J and I, not I over J, but J over I, because this is measured from shopping center I. So in this case, you need to put B over A. Yeah. So you get 1,000. This one I can remove 3. Oh, 100,000. I think I missed by one more zero here. Okay, so this one become 1 over 100. So become 1.1. So 4.5 from shopping center A. That means it's attracted. Huh? Yeah, correct. Is that correct or not? Why this is attracted to B? To be closer to A, right? Be closer to A. Yeah. I think this is probably first. The one that attracted must be A. Yeah. So I think this is reverse. Okay. So okay, let's practice this. Can you compute this? So if you want to open a new store, okay, and you see two location, residential center A and residential center B, and the distance is 6. Okay, so this is larger. Then the question is, okay, there are certain potential store location. So then your question now is whether this is actually who are your market, target market? Is it from A or from B? So you can try this. So if you go to Google and type that, I guess you'll be able to see. Right. That right. So exactly the same formula. Okay. And yeah, same formula. And you can, yeah, this is very old model. 29. The later model is similar to gravity model also, okay, proposed by Huff. You see? So this is predicting, instead of predicting the distance, okay, now it predicts the probability that the customer will visit certain site. Again, this is based on gravity model. So A here represent the attractiveness of the store, and D here represent the distance between the customer location to the store. This is the basically generalized cost model. Okay, and attractiveness multiplied by generalized cost divided by the sums. Okay, that represent probability, right? So, and this has been used even in urban planning, also in GIS. You can check, in QGIS, also in ArcGIS. Okay, these are example that we can use. Okay, gravity model, okay, for various purposes. Okay. I hope this is clear. So, did you practice the relay model? You want to share it? Yeah, correct. So 3.35, yeah. So the total is how many kilometers? 6, right? And then 2 kilometers from A, and then 4 kilometers from B. Okay. So you can also combine if you know this is just an idea. Okay. This is just an idea. So you can continue that if you want. Okay, so if you say you have 3 regions here, okay, and you have floor space represent the attractiveness. Suppose you get also the sales, okay, in terms of money, and then you also know the population. Okay, so in that case, we can just take the sum here, and suppose you also know the distance. Yeah. So in that case, you can check, okay, you can compute the output in terms of, okay, here. You can calculate, for example, from to, okay, in terms of function of retail shops. Okay, so the retail shop, yeah, divided by the distance. Can you see this? And then say I just put exponent of this delta or gamma. Okay. So this is parameter should be calibrated actually, yeah, because the larger means most shopper will prefer shorter distance, right? So you can get this based on the floor area, okay, and you can also get it from based on retail sales, same thing. Okay. From there, you can calculate the probability. See, this probability, of course, just this value divided by that value. Okay. The sum. Okay. So this is meaning retail expenditure flow as percentage of residential zone. Okay. Same thing here, yeah, as retail sales you can get, and then you can calculate the probability. Yeah, so I'll name this table B and table A, but I still have some problem. Okay, so I don't know why this is exactly the same. So, and you can also put it as function of population. Yeah? You can get certain values. So from there, you can get the output, okay, which is based on this probability multiplied by the 431. Yeah. And this one, oh, this one is the total customer expenditure. So total expenditure is basically N this one is this value. Yeah, total expenditure per person. This is a person, you just get the value from this F9. Okay, divided by N34, where is that? This one, the total population. Yeah. So this one is the total, supposed to be the total in sales, retail sales, divided by total population. Yeah. With that, we can get the output. Yeah. Okay. How much they will spend. Yeah. Okay, so we can predict not just gravity in terms of the trips. Okay? We can also predict in terms of spending. Okay? So it's possible to deviate away from the transportation and use it for something else. Okay? I hope you get the idea. Okay? So instead of trips, okay, you can change it into retail sales, and then from there you can actually get certain value of how much sales you can get. So the same model, okay, the same gravity model, but you make it into different purpose. Okay. So any question so far? So, okay, so in that case, we will end this trip distribution, right? So as what we have learned, okay. So we can simulate many interesting things, yeah, in urban spatial interaction, yeah, using very simple model of gravity. Okay. And remember, we discussed about general cost, yeah, value of time, okay, spatial interaction, gravity model, Rayleigh model also, yeah. Okay. And shopping retail, yeah. So I hope this is useful for you. Which one you want to share?
The last Excel, sir.
The last one, yeah, I can share, but this is not really working well yet. It's okay, I can share. I will put it in here for everyone. Where is this? Okay. Okay. So I can share this. Oh, okay, I will go. Okay. Again, share again. It rejected to share. Did you get it? Everyone? Yeah, this is just to give some ideas. Yeah. That you can also use the same gravity model for many other purposes. Okay, and so is there any question or feedback? No question, no feedback. You can continue with the mode choice then. Okay. So you can go to Moodle in the calculator and download the slide on mode choice. Okay. Yeah, in Moodle, you can go to mode choice. Okay. So this is the third steps, yeah, four-step models. Okay, trip chain, trip distribution, mode choice, and then traffic assignment. Next week is traffic assignment and mode choice. Uh, okay, so these are the topic that we would discuss in this slide. Okay, so mode choice depends on the purpose, the factor, okay, what kind of type, and some models, okay, and some statistic and mode choice. And usually we use binary logic model or multinomial logic model. Okay. So suppose let's start with certain example. Suppose one city want to implement new public transport, transit system, public transport to reduce the car trips. The city currently generate, say, 1 million car trips per day. Okay, and then the survey show that 30% of residents would consider to use public transit if it is available. Okay. The question is, how much is the reduction of car trip in public if this public transit system is implemented? Yeah. So of course, because 1 million car trips, okay, and then 30% of that, yeah, of course, 300,000. Okay. Okay. So you can get 300,000 potential reduction in the car trips. Okay. So here is the simplified version. So if you have a road, okay, in one road, how many lanes? Yeah. Oh my. Now these are the lanes. So per lanes, the capacity, okay, the capacity per lane is about 2,000. Yeah, about 2,000 vehicle per hour. Okay. So if you have 3 lanes like this, right? So you will multiply by 3, you have 6,000. Okay. So per hour, you have 6,000. So usually in the peak hour, right? This one, right? So if you have one day, usually about 10 times of the peak hour. So in that case, you can accommodate like 60,000 by the 3 lanes. If you use car, okay, you use car. So if you use transit, okay, it will potentially reduce because the number of people is the same, okay, but okay, the capacity per bus or per train is actually much bigger than in terms of number of people that can occupy in one vehicle. So that is the idea of mode choice, that we want to have choice to public transport. Okay. So now, depending on what kind of mode, mode of transport, it can be just walking or probably using streetcar or cycling or using car. Okay. Here is if they use car but using a freeway. So these are the measure in terms of distance. That means if you are actually very short distance, okay, you're supposed just to walk or using bicycle. Okay. But if your distance is more than say 10 kilometer, okay, then you probably need car. Okay. And if your distance is like more than 20 kilometer, so then again you need to use a car with freeway. Okay. These are some kind of idea. Okay, that in 1 hour commuting, okay, you are supposed to use different mode. Okay. And again, the streetcar is within this the same as bicycle. So don't expect you use bicycle, okay, to travel very, very long. Should be within just 10 kilometers. Okay. Walking is 5 kilometers. Okay. Cycling is about 10 kilometers. Okay. So the purpose of mode choice is to determine, okay, the number of person trips made by its mode of travel. So remember, from trip chain, you get trip production, trip attraction for each zone. Okay. And then from trip distribution, you get TIJ, which is the number of trips, okay, from zone to zone. Okay. Now, in mode choice, now you split this one. Mode choice, sometimes we call it modal split. and you split the person trips by mode. So instead of Tij now become Tijm. M represent the mode. So then the question is, what are the factors that make them choose different mode? So basically, mode choice is about computing the market share for its mode. Okay. So of course, the one important factor is the car ownership, availability. Okay. And this is also influenced by the family income, education level, and household structure. Okay, and the necessity. So when they have higher family income, they tend to use car. The same thing, usually higher education level, and not necessarily, but usually you tend to use car. Okay, and now if they have many people in the family, okay, again they probably need to use car. Okay? So there are certain work that you need to use car at work. For example, you are a driver or you are a delivery person. So then, of course, it is by necessity to use car. Okay, and in the US, for example, the residential density is rather sparse, and there is no available public transport, so there is no other choice except to use car. Okay. So, and then other factor represent the type of dwellings, okay, what type of residential area. So again, a higher or bigger number of rooms usually represent the household structure. Yeah. If you look at these factors, they are actually not independent. Yeah. There are certain factors that actually influenced by the other factor. Okay. Possession of driving license also one of the factors that probably can be used to check the mood choice. Okay. One important factor is the trip purpose. Yeah. Whether they are actually necessity, okay, commuting, or optional. And then depends also the time of the day. Yeah. If there is no public transport in the night, then of course they need to use car or motorcycle. Yeah. So, but the most important factor that you need to include in mode choice model are these two. Yeah. So this is basically like generalized cost, isn't it? And travel time, travel cost is basically generalized cost. So, okay, in terms of the cost, yeah, you can see, okay, and now you can make it more detailed. Okay, how much is the fare? How much is the fuel? Right? So, how much is the in-vehicle travel time? Okay, and if you are using public transport, and then how much is the waiting time at the stops? How many times they need to transfer or interchange? Okay, and then what is the walking time in the stops and station? Okay, so this represent the impedance, isn't it? So represent generous cost. Yeah. So again, you can also include any other factors which is qualitative in nature or intangible, using a Likert scale. Yeah. So 1 to 5 or 1 to 10 or 1 to 100 is up to you to decide. Okay. So the basic idea is you want to get, okay, how much is the market share for each mode, okay, mode of transportation, whether walking, cycling, or using car or public transport. Okay. So in the model, okay, there are two, okay, type of model. One is called aggregate model, and the other one is disaggregate model. Okay. So aggregate model is based on zone. This is the classical one. So based on zone, so you aggregate, okay, how many people coming from zone A to zone B. Okay. And this aggregate method is not based on the zone, but based on household or based on individual. Okay. And the studies show, okay, this graph is very important to show. Okay. Say, suppose this is the income, this is the vehicle trips per household. Okay. If you use this aggregate, okay, you will see these dots. Okay, and whether the green one or the red one. Okay, and this point represent the mean for zone A. Okay, this point represent the mean for zone B. Okay, so if you use this aggregate method, you will have two lines. Okay, this is the line for household A. This is the line for household B, which is the higher the number of income, the higher the number of trip per household, isn't it? Okay. So, but if you use aggregate level, so that means you take the average, okay, here and here, and then you plot, you will see a negative gradient, isn't it? So it means the higher the income, the number of trips per household is actually reduced, which is incorrect. Yeah. So this is called ecological correlation fallacy. Okay, there's a problem in the application. Okay, so in the zone, the trips is decreased by income. Okay, while in this aggregate, the trips is actually increased by income. So we know that this aggregate method using household or individual information is actually supported by customer behavior theory. Yeah? So in this case, you better use the disaggregate method rather than the aggregate zonal information. Yeah. So technique to compute, okay, historically based on two modes only. Yeah. One is called private vehicles, the other one is public transport. Okay, so just the two modes. So then we want to find the cost of mode 2 minus cost of mode 1. And then based on logistic function, it is this formula. Okay. So the curve will be like sigmoid, no? S curve. And this is the probability of Dij divided by the total. So this S curve is called diversion curve. Yeah? This represents the proportion of the trips using the mode divided by the total trips. Okay, so based on the relative cost and the ratio, the relative ratio. Okay, so if you use maximum entropy theory, okay, of this S curve, okay, eventually, if you derive mathematically, you will get this logic model. Okay? This logic model represents the probability of a mode, yeah, to go from I to J. Okay, okay, that represent the number of trips of that mode divided by the total number of trips. Yeah, this is one cell in the gravity model. Now we split into several modes. Okay, remember in gravity model you have many cells in the matrix. This is just one cell in that gravity model. Now you need to split it again into many modes. Okay, now you use exponential of based on the cost function of each mode. Okay, and then you use certain parameter value, beta. Okay, so we can simplify, okay, this value, okay, represent utility. Okay, because this is not just one factor, right? Not just cost. It can be generalized cost, isn't it? So generalized cost is a function. So let's call this U. Okay. So that U represent linear regression like this of many factors. Okay. So in case of binary, okay, then the computation is rather simple. Okay, so exponent of u1 divided by exponent of u1 plus u2, right? So this one, okay, this formula, you can simplify, okay? So on the top, you can put it as 1, then you can put it below. Yeah. So that is 1 plus exponent of u2 divided by u1. Yeah. This is exactly equal. And then this, because this is exponent divided by exponent, you can minus. Okay. So basically, this is logistic function, right? So now if you have more than 2 modes, okay, the same formula, okay, but now utility of 1 mode divided by the sum of all this exponential of utility. Yeah. Remember, utility represent some kind of linear regression. Yeah. So let's take example so that you can get the idea. Okay. Suppose the probability of using car and or bus, yeah, you have only binary logistic, yeah, between car and bus. So this is the formula. Yeah, the probability of using bus is 1 over 1 plus e exponent u. U depends on the this value. It's already calibrated. Okay, someone already calibrated for you. Okay, to get the 0.3, 0.18, these are calibrated already. So now these are the current travel cost by bus, the travel time, and travel cost by car and travel time. So these are given. Yeah. Remember, this is delta, so that means the difference. Yeah. This is also delta, so this is the difference. So the question, now suppose that Tij, that small cell in that using gravity method, you get a table. So this is just one cell of that, is 1000. Okay, between I and J. And then now, this is the current condition. Okay, using this model, if the bus fare reduced to now from 1.7, now become 1.5, how many people will use the bus? Yeah, you can estimate, yeah, using this model. And then additionally, okay, there is a congestion toll pricing of 1.5 adding to the car. That means this cost now increase, yeah, by 1.5. How many people again will shift from the car to the bus? The idea is you want to force, okay, people, middle class people, to use bus rather than car, right? That's the entire idea. So then what you need to do is to compute the difference in the travel cost, okay, and the travel time, right? So a while ago, you have 1.7, okay, and 2.9. Yeah, okay. So the difference is 1.2, and then different in travel time. Okay, here 2.25 hour, okay, and this one is 75, right? So then the difference is 0.5. So then we input that difference into the utility. Yeah. Remember the utility depend 0.3 plus 0.18 times delta cost plus 1.95 times delta travel time. Yeah. Delta means the difference. Okay. So then you get this value. Yeah. The utility itself no meaning, just number. But when you input that into the value in this formula, you will get probability value. Okay. So you get initially you get 38% to use pass under the current condition. Okay. Now scenario 1, the bus fare changed into 1.5, right? So in that case, the bus fare a while ago was 1.7, okay, now become 1.5. So in this case, now this one become 1.4. Yeah, because this is the difference, okay, in terms of the cost to the car between bus and the car. Okay, and then you get new value, input it into this formula. Okay, and you will get 39%. Okay, so because the TIJ is 1,000, so that means you have 396 people will use bus. A while ago it's only 387. So there's an increase, okay, about 2%. Or what happened if we do congestion pricing? The car cost increase, now become 4.4. Okay, and then again you computed the utility and the probability, okay, and then it will shift become 440. Okay. So compared to the initial 387, okay, so you get additional 53 people that will use pass. And this is prediction. Okay. So based on the simple what's this, logic model, okay, if you know, if you have calibrated already, then you can actually get the scenario. Okay, what if I do this? What if I do that? Okay, so these are the least example of scenario that you can apply based on the mode choice model. Okay, or what will happen if you do exclusive right of way for public transport? Yeah. What will happen if you do change in the fare policy? What will happen if you put fuel tax, for example? What will happen if there is a parking fee adjustment to the car, and so on? Okay, so what will happen if you have new highway, okay, and so on? So using this, you practically can simulate many things using the same model. Okay, so up to here, is there any question? So I think I will stop up to here. Okay. You can read the model itself, how to compute the model in there. In Revoledo model, there is a logic model using Excel. I think there is also assignment, isn't it? I think I will delay this to 31 assignment. 31 of November. Okay. So thank you very much for today. Okay. For those who still want to continue the midterm exam, they can do so.
Thank you, sir.
And okay, there's a question here. In the forecasting assignment, if the model, if okay, loan was exponent transform, okay, so because you are using loan and exponent in that assignment, okay, so of course you need to put if. Okay, if the value of loan is actually 0, then that if error, we put it 0. Okay, otherwise it will not run. Or if the exponent is very big, okay, also not working. So in that case, you divide first the value, okay, with certain number so that the value is rather small. Okay. Remember, exponent is the curve is very big. Okay. So and then it will become known that is because your exponential to large number. So in that case, you just scale it down to small number. Yeah, say between 1 to 2, for example. You can scale. So thank you and see you next week. For next week, can you prepare your presentation? Is it okay for the group project? Just a progress report. So see you next week, guys.